through a sound wave. Okay. Those sound waves come like this. Basically what they do, what it is it's basically air pressure. So what you're actually graphing is the amount of pressure that your ear is experiencing. Higher pressure pushes your eardrum in, lower pressure lets it come out. In, out, in, out. Okay? And the speed at which that happens, your ear and your brain translates into lower or higher notes. Okay, so a higher pitch will come fast, you'll have more of these in it in the same amount of time, right? Because the speed of sound never changes. You just have the compression wave is coming faster, so your eardrum vibrates a lot more, and it sounds like a higher pitch or frequency. Okay. Longer, slower vibrations of your eardrum produce lower sounds. Right. What I'm going to show you today doesn't take the fast or the slow into account. It's just the basic sine and cosine curves. Okay. So these functions, so remember the unit circle, okay? Keep this in the back of your mind. It's never going to end. So you can stab yourself in the eye all you want. Right? Okay, what is one cycle of the unit circle? 0 to
360.
Ooh, what?
2 pi? Okay, we're in music terms now, so 360 is correct, but we want to be getting in the mode of radians. 2 pi, right? So, one cycle is 2 pi, and then it repeats. Right, so, one cycle, or one period, okay? If you are talking physical measurement, wavelength, I'm sure there are other words too. Okay. Cycle and period both refer to cycle, an amount of time basically. Wavelength is like a physical measurement, like 3 inches. Okay. So these are both time-based. And this is a measurement. Like when we looked at the Rubens tube, the fire, you could see how long that wave actually was. That's wavelength. We have amplitude. What does an amp do in your car? It's too loud, you're too old, right?
Yes.
Okay, so the amplitude controls volume in music. These items coupled with the speed of sound control the pitch or the frequency. Okay, so pitch and frequency are a matter of these items, like the length of the wave plus the speed of sound. Okay, so the frequency that you're finding for your notes has to do with it's in hertz. It's cycles per second. Okay, so in your music application, your A note was 440 hertz. So 440 of these cycles every second past your eardrum. Yeah. It's really amazing how fast things happen in the real world at the microscopic scale. and how slow they happen on a geologic scale. Right? So, the breadth of how finely tuned our world is amazing.
Cycles per second.
Hertz? Oh, Hertz. Like the car rental company? Hertz, HZ. So I assume you guys know these things. I think cycles per second. Yeah, I didn't know this at 15, let's just be honest.
What is that?
Yeah, well,
I didn't know.
let me see if I didn't miss anything.
Yeah, they have a long They had poverty scale everywhere. You saw one happy
All right, so there's your setup. I've been talking, I'm apparently blabbing today. Okay. Let's graph. Again, keep in mind this is a parent function. And anything we do to it's going to manipulate it just like we've manipulated all the other functions we have. Left, right, up, down, shrink, or expand.
Right.
Okay. But today, just the parent. It's based directly off the unit circle values. So, what's sine at 0? Okay, we'll move to, let's say, power 2. Sine at power 2?
So sine is 1.
1. Okay, sine at power 2. Power 2 is here.
Yeah.
0, 1. Okay, pi?
0.
Yep, the y value is 0. We gotta go to 2 pi because it's a periodic function. It repeats the periods 2 pi.
3 over 2.
So we'll just, it's easy.
Wait, what does that say?
3 pi over 2.
Negative 1.
Yeah, we're now at negative 1. And then 2 pi.
Negative 0.
Not something. Negative 0. Doesn't exist.
Okay, how come it's but they can't use?
How can you have a negative of no value? There's no value, how can it be negative? Or positive, it's not positive either.
It has to be null to have no value. And I don't see no null.
Okay. So, plot those points. 0, 0, pi over 2. Now we're using a little bit of a different x scale now.
Yeah.
Because we have radians. 1, pi, 0, 3 pi over 2. They don't balance. Negative 1, and then 2 pi.
Did you see that?
I see what this is going.
Did you see the waveform?
Yeah.
So again, it's basically directly based on your unit circle values. And that's one period with 2 pi units of sine x.
Some variations will just change the wavelength and stuff.
Yeah, so you can shift it left, right, up or down. You can change the amplitude, or you can change the period or wavelength. Musically, we don't shift this at all. Okay, all we do is shrink or expand it for pitch differences, high to low notes, or change the volume. Okay. So for your project, all you have to do is shrink or expand either way. I mean, we're not going to be shifting a lot. Any questions? Okay, so the period, so we can go through. The period's 2 pi, right? So if I kept going, it would just keep going. What's the domain? Remember that word?
That was the X value.
Yeah, so what possible x values can go in sine x?
You had
Like all the pi values?
Yeah, what values can I put in for x and get a result?
Any multiple pi.
No, you can put, I can put anything in here, in it. These are just nice unit circle numbers, right? So, but I could put 0.4 radians in and it would spit a value out if you had the table at the calculator.
So any.
This is all the real numbers. You remember that notation?
Yes.
How about the range?
1.
Yeah, -1 to 1. Okay, so, or you could write it like that, doesn't matter. Close parentheses, close. Sorry. They get an AP mode and they don't care about parentheses versus brackets for some stupid reason. And I just don't worry about it. Yeah, they do. So we have the domain and range. Okay, again, keeping in mind the range is, what's the amplitude here? So based on here, how high does it go? There's your amplitude. Okay, so 1 unit either side of the x-axis.
Hey, does the extra
Mathematically, we say it is, but if you turn your stereo on, there are stereos that have negative volume, right? 0 is their maximum, and negatives go down. What's the y-intercept? 0. Nice. There. And we can go through and analyze this graph just like we have any others. X-intercepts?
Pi.
0, pi, 3 pi, 4 pi, 5 pi, 6 pi. How, right? How would we write that formally? Do you remember? These are multiples of pi, right? So we would write it pi times n. Okay, n is an integer.
0 and pi.
Positive and negative whole numbers. So we can go, that phrase covers an infinite amount of possibilities. There's a couple other things even. We have a maximum.
Yes. Could be that.
How many maxima are they? Yeah, they're an infinite number because it just, right, so, but what's this one? The maximum value is 1 at,
Pi times
Oh, and then,
Oh, yeah. When you could do that, it's
You have to just say it has negative 2 because it has negative ones.
okay, so minimum, -1 at, so your graph, again, all the skills we've talked about for graph analysis are still coming into play. there was one other. Where is this graph increasing?
0 to half pi.
0 to pi over 2. Or half pi. Yeah, that works. And? Yeah, 3 pi over 2 to 2 pi.
Yeah.
And then decreasing,
Just flip it.
flip it. With it. What it? There's a lot of its on here.
One to
Pi over 2? To 3 pi over 2, right? Because we're going down to the right. Okay, so a lot of information there, right? And now you're bored. Music piqued your interest, and then I did math.
That was brutal.
Right? Okay. So, we probably won't use a lot of this information very much. Okay, the graph is going to be the big thing with these period and amplitude being key. So, you good?
Yeah.
This is
Okay, Tyler's good.
I'm good.
Who's kind of good? Kind of good. Who doesn't get it? Anybody want to admit it? Oh, the old world.
Wait, so are we gonna put all that information when we do our own chords and stuff?
No.
On
Like I said, you're only worried about really amplitude, period. All of our music starts at 0 because,
Yeah.
you know, strum start at 0, easy.
In periods when they all connect.
That's pretty much the extent of what we're worried about for music. The rest of it is mathematical
Is there
analysis.
any guarantee for like if we do all of that?
If you want to, so, you know, part of what you'll see in a math project is anything beyond what I ask you is showing advanced knowledge of the topic. It's gonna bump your grade up. Okay? It is considerably harder to find these values with the notes where we're gonna be working with, because the functions are, instead of sine x, it'll be like y equals sine 880 pi x. And that right there is what messes with your period. All right, cosine. Cosine is the same as sine, it's just shifted 90 degrees or pi over 2 units. That's it. Okay, so it's the same development using a table of values from the unit circle. What you'll see is that it's just shifted a little bit. Fill that in based on your knowledge of the unit circle.
I don't have any knowledge.
Or use your unit circle printouts
Let me just
if you need to.
order 901. 0.
Maybe. Periodic functions follow patterns. Yes. Again, the goal is to get this memorized, so like the unit circle, have it memorized, and these need to pick them up.
This looks like code. 1 0 1 0.
Michael, do you have a value? for 0, cosine 0.
It'd be 1.
AJ, 5 or 2. He listens well when he wakes up. Okay, Sierra,
-1.
Logan,
0.
and you see the pattern. What's it going to be?
3.
I guess it's
51. No.
There's nothing in there. It's just free space.
Mr. James is paying me like What? His was VV 69, 69, and mine was like VV 96, 69.
Next good week, you should make one just
So there's your cosine.
Why are you talking
So, again, cosine is just a shift of sine. So if I did this and covered this one up, what does that look like? The sine graph, right? Sine graph, you just shifted it left 90, or pi over 2 units.
Gotcha.
So,
Negative.
if you combine the tables again, we'll see that leftward shift.
It's not negative.
The y-intercept is
1.
1.
Thank you for telling me it's negative.
The x-intercepts,
Pi over 2.
is there a minimum?
Yes.
-1 at, and the maximum? 0,
0 and 2 pi.
2 pi, 4 pi, 6 pi, 8 pi. What's the period? 2 pi is your repeating mark, right? So all that same analysis can go into cosine. Very similar to sine. It's just a small adjustment. Some of them are exactly the same. Domain, range, period, amplitude, all that stuff is the same. Questions on sine, cosine parent graphs?
No, actually.
All right, so some of the things you'll run up against. Let me give you one example. Graph y equals sine x from pi to 3 pi. So we don't give you the standard window, but different values.
Also, we just start at the x-intercept.
You go pi to 3 pi now.
It would just go down, and then start to kick back upward. Yeah.
Yeah, because your 0 to pi looks like this, right?
Yeah.
But then pi to 2 pi, and then you repeat the hump. It just keeps going. So basically what you're doing is trying to figure out which part of that graph you're looking at.
Never understood it.
Okay.
Could you find graph y equals tan of x?
Yep,
Why?
I could. Lots of places to find it.
Is there a parent graph for it?
Yeah, there is. Here's,
You can just sign in cosine, right? Just go for each other. They won't give you See?
why does it look like that?
Looks like
That's tangent x. That's a few days from now.
A few days.
Why does it have a vertical asymptote every pi units?
I don't know.
I thought you're supposed to
Well, think about it. Tangent is sine over cosine. Why is there a vertical asymptote?
Cancels out opposite.
The denominator is 0. Sine over cosine, right?
Right.
So where cosine is 0, vertical asymptote. Right, so if we look at our cosine graph, vertical asymptote for tangent, vertical asymptote for tangent. This is just neat for me. Okay, so I'm going to be done talking 100 miles an hour. Take a chill pill. Any questions?
Yeah.
You'll be asked unit circle values, graph functions, and then for your projects, make sure you grab those frequencies. Okay. All right. I do have some work for you today. I'm not going to forget this time.
Got really excited.
Whoa. Does anybody do any homework over the weekend? Because it was posted on Classroom, I believe.
I haven't been downstairs.
Okay. There's the practice. Do tomorrow, and then project. I'm just going to put what you should have done. Okay. Music chosen. Chords chosen. Notes. Breakdown. And then the frequency of the notes. Is where you should be. Looks like Thursday I will teach you how to insert your frequency into your function. Okay? Tomorrow I teach you how to adjust amplitude and period. And Thursday we insert new periods in your music notes. So Friday's to be determined based on the week.